Hey everyone, welcome back to the Rust Review. I'm Brandon Conkle. I've been a full stack developer for more than 15 years, and Rust is my favorite programming language because of the unique way it tracks value ownership in lifetimes. It provides strong memory safety and the kind of language features you would expect from a high-level language built on top of awesome low-level performance without a heavy runtime or garbage collection. On this show, I sift through articles from topics from sources like This Week in Rust, the Rust subreddit, the Rust tag on Mastodon, Discord, fellow Rust stations, and more to find interesting topics to share here with you. If you've got an article you'd like to see featured on the show, let me know in the comments or in the Rust programming language Discord, where I lurk as B. Conkle. I'm late on releasing an episode today because I just wrapped up a long-running engagement with a great client and needed to take some time to ensure a solid transition and sort some things out afterwards. And in my time between projects, I'm working on some blogging that I'm really excited to share soon. First up, I'm going to be talking about the kind of event-driven API architecture with AWS Kinesis that I've been working with lately. In the meantime, though, I've been keeping up with the Rust community, and there has been a lot going on. In this week's episode, I'll talk about the Rust Linux Kernel developer that stepped down a week ago, what's coming up at RustConf in Montreal, templating in Rust with MiniJinja, arenas, which is a new concept to me, but still based on familiar things, tractors, which is a fascinating thing, other podcasts, and more. Today, I'll start off with the big story that has been, I think, all over the place. The Rust kernel Linux maintainer that stepped down, citing non-technical nonsense. So if you've been paying attention to the Rust world, you've probably heard about this story because it made big headlines a week and a half ago or so. One of the maintainers of the Rust for Linux kernel project, he works for Microsoft and has been focusing on this. He stepped down. He resigned about a week and a half ago, citing just the kind of culture, the kind of attitude, the kind of opposition that he has experienced in working with Linux kernel maintainers in general. So it's Wedson Almeida Filho. He's a Microsoft engineer, like I said. He's been contributing to for 4 years, I think he said in his resignation post. He's worked on all kinds of different features, but he's stepping down, and I think he has a good reason to. I'll go into detail, but his resignation post says, "After almost 4 years, I find myself lacking the energy and enthusiasm I once had to respond to some of the non-technical nonsense. So it's best to leave it up to those who still have it in them." He thanks the Rust team, the Linux kernel team, for being a pleasure to work with, and says he truly does believe in the future of Rust or memory safe languages in general for the Linux kernel, for kernels in general. And he says, he gives kind of a warning that really got me thinking. He said, "I'm no visionary, but if Linux doesn't internalize this, I'm afraid some other kernel will do to it what it did to Unix." And if you don't have the context, the history there, the Linux kernel essentially ran circles around Unix and ended up being the dominant force on the internet for server technology, whereas Linux is just kind of relegated to the sidelines for special cases where you really need proprietary features and support. But really, most everyone focuses on Linux now. And so he's warning, if Linux keeps going in this direction, if the kernel team keeps maintaining this kind of culture, essentially, of exclusion, then some other kernel is going to come out and start running circles around Linux. And I think that's that's a cogent warning. That's something that really could happen. And I think the Linux kernel maintainers have done amazing work. I think they maybe rested on their laurels too long and don't recognize the possibility that they could fade into obscurity. I think the Register, they had a pretty good follow-up on this a few days later. They start out outlining the situation, but then they talk about some of the context around it. One of the things that that Phil Ho referenced in his resignation post, kind of to give evidence of the kind of thing that he's seeing. So this is like not the one thing that caused him to resign, but this is a public piece of evidence that shows really outwardly, this is what I'm dealing with, essentially, is what he's saying. So he talks about this video. It was around Linux file systems. I think I've got a link to it somewhere else. I'll make sure I link it in. Oh, there it is. There's the YouTube video. I'll kind of show the context here, but in this video, there's a lot of opposition. There's a lot of argument, a lot of pushback, and the reasoning behind it doesn't really convince a lot of people about the Linux maintainers' genuine desire to work with outsiders, to cooperate. So I think the one of the pieces of this video that's drawn a lot of attention is Ted So. He is one of the main Linux kernel maintainers. He's been around for a long time, I think since the beginning, since early on with Linus. And the central contention in the video is the Rust maintainers, Phil Ho and his team supporting him, want to know what this kind of abstract behavior is in a certain part of the kernel code. There's, I'll try to simplify it as much as I can, but essentially there's a part of the kernel code that doesn't really have static typing, that doesn't really have like encoded expectations to what the behavior may be. And so the Rust Linux maintainers request was simply to let us know when that changes, to keep maintainers of things like Rust Linux kernel support apprised when things change, and let them know what breaking changes are coming up. What essentially it's wanting them to take on the burden of communication that comes with letting people know exactly what's changing and how in situations like these. And that seems to be the contention. The pushback seems to be that they don't want to take on that burden of communication. But I think they're framing it as a rejection of Rust. And my contention, or my argument against that, is that this would apply whether it was Rust, whether it was Zig, whether it was any other kind of language. Basically, they're pushing back on anything but their C code, because they don't want to actually take the time to communicate with everyone exactly what they're doing, exactly what that changes. And I think Phil Ho had enough with that. So the register followed up with Phil Ho and tried to follow up with So also to get his perspective on this, but got no response. But Phil Ho did respond to the register and kind of outline more. He said that he fully expected they'd get pushback. I mean, anybody who's observed the behavior of the Linux kernel team over the last decade or 2 decades or more understands that they've dealt with toxic behavior. They've dealt with a lot of contention and interpersonal conflict for a long time. So he knew what he was stepping into, but I don't think he realized just how pervasive that would be. Basically, the register simplified it down and just said, do kernel maintainers need to learn how to play well with others? And he kind of hedged around it, but really that's what the ultimate contention is here, is that they don't want to play well with others. It's not specifically Rust, although they seem to be making it about Rust, because I think they want to take advantage of some of the community sentiment in the C community against Rust, against outsiders coming in and trying to take over. But that's not what they're doing. So in Ted So's comments around this in the video, he specifically called out that, whoops, I accidentally highlighted something here, but in the video, Ted So calls out, here's the thing, you're not going to force all of us to learn Rust. And Phil Ho directly responds to that. He says, to reiterate, no one's trying to force anyone else to learn Rust or prevent refactorings of C code. They're not saying you need to learn Rust and fix the Rust if it breaks. They're saying when you refactor C code, you need to have clear and open communication about here's exactly what's changing and how, so that maintainers of things like Linux, Rust kernel integration, or Zig or any other language knows what to expect. They can encode that in the static types, which is the whole point of ensuring this kind of stability. Yeah, this is a situation that frustrates me because I love Linux. I have been a long time Linux user. I'm on Arch Linux right now, which is notoriously difficult to configure, but I love just the low level control of everything and the customization of every layer that I can engage in. But if this is how the Linux community, the Linux maintainer community, the core team is going to view things, not embracing innovation to try to allow more people to do more things with Linux, and instead trying to take more of a protectionist approach and entrench their positions and their approaches and their specific preferred tools that they've used for decades. I don't think that it's going to have a rich future. I think that Phil Ho is right that something else is going to come out and really undercut Linux's prevalence in the server community and in all kinds of different ways, I think. There is a lot of great discussion in different places. There's discussion on Mastodon. There's discussion here on Reddit, in the R Linux subreddit. There's some great discussion. And honestly, I was a little bit surprised at how supportive of the Rust maintainers that the r/Linux subreddit is. There's a lot of talk about really just not being shocked, being dismayed, maybe not surprised, but not really liking to see this perception of the Linux kernel's disruptive behavior be proven out true time and again. And here it is, another case where the culture, the behavior around it is so toxic, it's turning people away. I think that that's going to be a serious problem for Linux going forward, and the people of the Linux subreddit seem to agree. And then similarly, I guess you would expect this in the yep, I've got to bring my screen sharing back up because I hit the wrong button, but you would expect this in the Linux subreddit, but then also in, or I'm okay, yep, reframing what I was just saying. In the Rust subreddit here that I've got pulled up, you would expect a lot of defense of Rust, and you see that definitely shows up here. But there's that same kind of support for Rust and dismay against the maintainers in the Linux subreddit as well, which was surprising to me. So I really think that Linux maintainers need to recognize that C is not the end all be all. It's not going to be the core of everything forever, and they need to start taking on the kind of communication that is needed to work together as a team. They need to show that they can work as a team, even with people that have different priorities, different agendas that they do. We can interoperate, and we don't have to be aggressive and entrenched in our positions. We really need to be able to work together with others in order to move forward. Hopefully the Linux maintainers will take note of the rather strong reaction against their behavior and start to make some real changes. All right, so next up, let's shift gears and talk about a happier topic. Let's discuss what's in store for RustConf 2024. From what I understand, this is the first RustConf to take place in Canada. They're going to be in Montreal from September 10th to 13th, so just tomorrow, as of the time that I'm recording this, and stretching through, through the whole week. Yeah, it's going to be through Friday, which is awesome. It's going to focus on some key themes that they've called out here. Security, obviously a very big concern right now as adoption of Rust grows, performance and optimization, and Rust in more places, in more context, being used in more industries. There's a total of 4 exciting keynote talks that they describe here. So I'll pull it up. They've got Making Open Source Secure by Design, presented by Ava Black, the open source security lead of CISA. We've got An Outsider's Guide to the Rust Project, presented by Jack Huey and James Munns, their Project Leadership Council members. There's a Rust for Linux talk by Miguel Ojeda, maintainer of the Rust for Linux project that we just talked about, another maintainer stepping down from. I'm hoping, or I'm curious to know whether he addresses that at all and talks about how to move forward given the adversity they're facing. And then Nicholas Matsakis, co-lead of the Rust language design team, is going to be presenting the Rust Roadmap 2.0 to talk about the goals Rust has set for 2024 and ideas about where they could go in 2025. There are a number of other great talks, it looks like, lined up there. This seems like it's going to be a great event. I wish I could go. I had actually planned on pitching a talk for it and just ran into time constraints, but definitely excited to see what happens. There's going to be some hands-on workshops tomorrow as well before the conference starts. But since I can't be there, I will definitely be taking advantage of this, the virtual experience. There is a Discord channel that will have information about the live streams, the Q&As, letting you interact with other attendees and speakers, even though you're not there. And I really appreciate them doing this. This is something I think conferences have been doing more and more since the pandemic happened, because it's not always possible for people to join physically. And I appreciate that consideration. I'm glad that they're doing this. Next on the docket is a post from someone who I have been following for quite a long time, Armin Ronasher. He has been a major fixture of the Python community in the past and has stepped out into other language ecosystems like Rust in recent years. And he's had a lot of great open source projects that have seen a lot of adoption. But one of the big ones that is seen a lot in the Python community is Jinja and Jinja 2. It's a really powerful template engine. It's similar to Django's template engine, and I think they've influenced each other over the years. And he worked on recently a Rust translation, which is really interesting. So obviously he loves template engines. He says in his post here from a few days ago that he can't stop creating template engines. Rust or Jinja is definitely not the only time that he's done this, but so stepping in with Rust, it's an interesting challenge because templating engines essentially allow dynamic code execution based on what's happening in the templates. And so he talks a little bit about the challenges of implementing a template engine in Rust and some of the ways that he approached it, some of the trade-offs that he made. It's a really great article if you're interested in this kind of pattern, these kinds of approaches in Rust, enabling some of the same kind of developer conveniences that you'll see in looser, more dynamic language communities. So he's talked about HTML templating and about, is it relevant anymore? Do people still create a ton of HTML on the server side rendered with template engines? And no, they don't as much, but there has been some resurgence for things like HTMX and Livewire. But we've also seen it in other contexts. It's come up a little bit in large language model prompt generation, things like that. So there's definitely still relevance to HTML templating engines. So he's been working on MiniJinja in Rust over the last 2 years, which was surprising. I didn't realize he'd been adding to it for so long. He's got it to the point where it's almost at feature parity with Jinja 2 in Python. And he says it's quite enjoyable to use, which sounds great to me. But he talks about the challenge of runtime values. So he talks about when building a template engine for Rust, you end up building a little dynamic programming language that's optimized for text generation. He says the interesting bit here is how to create a system that allows interactions between the template engine and the Rust world around it. So it's going to be similar to like plugin authorship or executing untrusted code, which I've talked about in previous podcast episodes before. Some people reach for scripting languages that are similar to JavaScript or things like that. But in this case, when you're focused on text generation, he cites the kind of challenges that you run into. He opted to stay away from code generation, which I believe that's the approach of Jinja 2. Yes, he says, unlike Jinja 2, MiniJinja doesn't use code generation, but instead has a stack based on a has a stack-based virtual machine and an abstract syntax tree based bytecode compiler. Wow, that's a mouthful. But he says this, it inherits a lot of behavior from Python, from Jinja 2. And this causes challenges because it's easy to create cycles, he says. And Rust obviously doesn't have a garbage collector that can help with this problem like it would in other dynamic language ecosystems. And so he goes on to demonstrate what that means. He talks about how, look, some of these types have an arc around them, and talks about why that's needed. He talks about using arc for reference counting in this kind of dynamic environment. And it's really a fascinating article. It goes in detail about a lot of things that I don't have great familiarity with, but I've certainly used on the consumer side. I have used templating engines a lot. I've used Jinja 2. I've used some of the JavaScript ports, and so it's interesting to know how much work goes into them behind the scenes. And he even goes as far as implementing adjacent borrowing with unsafe code because there's not really any other way to do it. So definitely an interesting post, a detailed post. So definitely take a look at it if you're interested in this problem domain and you're ready to dive into lexing and parsing and things like that. Armin, he's a fantastic developer. I've been following him, a long time now. I joined Lincoln Loop in 2010. It's a well-known Python consultancy, and I joined it right after he left Lincoln Loop to finish out his degree. So I've been kind of following where he's gone from there ever since. And I think he's doing great work. He's tackling some big things in Rust that are very challenging to do with the kind of strict type system that it has. So definitely check out that article for some fascinating reading. Moving on to an article that might be surprising to some people, and I wanted to acknowledge it and to talk about why I don't totally agree with it, but I definitely respect the opinion that Sylvain Kerkora shares here on his blog. He's definitely focused a lot on security, and I've covered one of his articles before. And this one just came out a few days ago and expresses a sentiment that I think a lot of people have about Rust, but I feel like it's a little misplaced. So he talks about, you see big names, Amazon, Cloudflare, Discord, they're building servers in Rust, building APIs in Rust, but he says it's not really a good idea. He calls out there's kind of a cool kid mentality, like we're doing the new hot thing, and he wants to push back against it. He says that Rust is a great general purpose programming language with a sophisticated compiler that catches many bugs for you, but it also has a major drawback that'll make you regret ever having picked it to build a server. And what that regret is the library, the language ecosystem built around it, the packages that are available. He says that you need more than just a solid language to build solutions to real business problems. You need a strong ecosystem of libraries that'll save a lot of time and avoid reinventing the wheel every time. And he's right. That's true. But he says Rust's ecosystem of libraries is not just immature, it's worse than that. And here's where I have some contention. He says that there are really high quality libraries like Hyper and Tokyo, But because these libraries are not official, they're not part of the Rust project or their maintenance or their extended standard library, there's constant churn for libraries that everyone needs, like datetime and crypto libraries. And he says that with time, over time, it seems like the ecosystem is fragmenting more and more, with new libraries popping up every month and others being abandoned just as often. And there is definitely some truth to that. I think there has been some churn, but I think that it's not going to last forever. I think that it's temporary churn because the async ecosystem has really just started to solidify over the past couple of years. Async Rust has been available for much longer than that, but there's been some big blockers preventing people from adopting it previously that have been resolved over the last couple of years. And so the async ecosystem is stabilizing. And I think the period of time that you had before that it stabilized, there was a lot of question about, is this really going to stick? Is this really going to be the direction that people go for async IO in Rust? And some of the big libraries like Diesel for SQL, for a SQL ORM, or Juniper for GraphQL operations, they're not async. They're based on a synchronous thread. And so if you want to use them with something like Tokio, you've got to jump through some hoops to communicate effectively with that single threaded channel, that thread that is running the synchronous code, and communicate with it through channels. In my last podcast episode, I talked through an article that illustrated the challenges of that. So it's not straightforward, and it's not easy to do something like that. And so I think there were strong libraries that were not async that were still do have a lot of the market share essentially in Rust. And there are new libraries like async GraphQL that I use as an alternative to Juniper, or CORM that's a good opportunity, or a good alternative to Diesel, even though it's more opinionated, I think. Libraries like that are popping up, but I think it's for a reason. It's not just churn. It's not just because people keep abandoning things left and right. It's because there was a significant shift in the language as async stabilized, and as some alternatives to some of the synchronous only libraries came out. Now, I will acknowledge that that's certainly not the whole problem. He's right. There are some people abandoning libraries. There are some churn on some things that everyone pretty much needs. But I think that this kind of criticism is the same kind of criticism that was leveled at Node early on, Node.js. And it has emerged as a powerful force on the back end, especially as the front end has grown more advanced and interactions between the front end and the back end have been enabled through things like React. I think you saw a lot of people criticizing Node and its ecosystem because there was churn. There was libraries that would go unmaintained for a while and be abandoned, and there were new alternatives that would pop up to different libraries. And as ECMAScript became more pervasive, as you started to see people transpiling their code, and then you saw engines come up that handled things like ECMAScript, and then later TypeScript as first class members, there was a lot of churn. There was a lot of things changing, and people in the JavaScript community complained hard about it because it really did bring real pain, real friction and roadblocks to maintaining a Node application for production over the long term. You couldn't just set it and forget it and let it run behind the scenes. You had to actively maintain it and upgrade your dependencies. And I think that's true whether your ecosystem is in churn or not. Even if you have a more mature ecosystem where the right solutions to common problems are obvious, there's still a lot of need to keep your application up to date, keep it updated, keep your dependencies up to date, because security vulnerabilities pop up all the time, and long-running bugs. I've seen in a lot of cases where a bug may have been going for years and nobody really understood what was happening, and then they finally fix it and it makes a big difference, but people don't update, and so the bug still hangs out for years. That's not specific to Rust. That's not specific to Node. That's any language ecosystem. But I think Sylvain's criticism that Rust is in a particular state of fragmentation right now definitely holds weight. There's definitely things that are in a high degree of churn, not only because async landed finally, or it's not that it landed, but it's become more stabilized as things have been fixed, as the roadblocks have been cleared. It's not just that, and in fact, I think some of the churn too is because things are moving more slowly than people expected. I think people like me observing the JavaScript ecosystem just go off like a rocket and change every other week. It's a big difference of how Rust has evolved more deliberately, more slowly. They've taken their time to figure out what's really going to be the best solution for the widest degree of consumers, rather than picking what seems like the right answer and then moving forward and then running into some other problem that they didn't anticipate and having to change things again. I think Rust is doing the right thing as far as the language, the governance of the language is concerned, and the ecosystem is probably churning a little bit because it's moving so slowly and people want things to change faster than it really is. And so you'll see some people abandoning libraries and moving on to other language communities, or maybe even giving up on async and going back to Diesel and Juniper and things like that. But I don't think that this is permanent. I think that now that Rust async is starting to become more usable for more use cases and in more contexts, that people are going to be abandoning their projects less and less as they actually start to get a lot of real value and use out of them. As they're building production projects that depend on these things, they're going to maintain them. And that's something that's going to take time to shake out. But I don't think that Sylvain's his assertion that this is happening because Rust isn't supporting these libraries as an official part of the Rust project, I don't think that's necessarily true, because I think in Node, there are a wide variety of very important tools that everyone depends on that don't go through huge amounts of churn, like Webpack, for example, that is not an official Node project. But it is a vital part of the Node ecosystem, and it is well maintained because so many people are using it and contributing to it. I think that's how Rust is going to evolve too. I think looking at the trajectory of Node and how it's evolved over time, you'll likely see a lot of similarities in Rust, just at a slower pace, and that's on purpose, and I think that's a good thing. But there are some things I think that he calls out, especially things like crypto primitives. That's a really good point, because he calls out Go in contrast. Then the Go standard library, it contains all the crypto primitives you'll ever need, and they've all been written and audited by experts. This is something that I agree. There's not a wide degree of different needs or variations that a single library couldn't support. The crypto primitives really could be a major part of the Rust ecosystem, but something like Hyper, I think, doesn't really belong as a part of the official Rust standard library, because I think there's a lot of different ways that you can approach an HTTP server. There's a lot of different ways you can approach concurrency and spawning tasks, and I don't think embracing a particular opinion and in embedding it in the Rust standard library is the right way to support all of those different use cases. I think that'll actually cause some friction against anyone who's not doing anything in the standard library. They might have really good reasons for doing it differently, but if it's in standard library, there's going to be a lot of pushback for them doing it differently, even if they have a really good reason why. I don't know. It's definitely a concept, or a dilemma with a lot of different shades to it, a lot of different perspectives, and I think there's no one true way to approach it. I think criticism like this is really valuable, and we should listen to it and pay attention to it, but I don't necessarily agree with everything that he's asserting here. Great blog post, though. I think he's got good reasoning to back up his ideas. All right, so now I'm going to move into something that I really was not familiar with, even though I understand the basic concept behind it. I haven't seen arenas as a formalized design pattern before. So this was really good. It kicked off some research, and I looked at some different sources to learn about arenas. And I like it. I think it's a really interesting concept. This blog post is from Jonathan Dernselman. I'm hoping I'm pronouncing Dernselman correctly, because it doesn't show it over here, but it does have an umlaut over the O. In any case, this is a great post that he posted, talking about what they are and why they're not just a vector. He says, in their most basic forms, they're just a vector, but with some extra guarantees. And he says it's those extra guarantees that really matter. So basically, an arena is a way to store your data somewhere without going through the system allocator. And that's kind of a confusing way to describe it to me. Basically, it's a way to hold a bunch of objects in memory that you don't want to be automatically deallocated, whether that's through Rust's ownership system, or whether it's through garbage collection in another language ecosystem or something like that. It's basically, you want to hold some objects in memory. You want to make sure they don't get deallocated until you're ready for that. And that's a really important thing to be able to do in high performance or compute sensitive operations. You want to be able to time the deallocations or the allocations in just the right moment so that it doesn't disrupt anything else. And so you could do this with a vector, but he says there's a big problem with vectors. If you store data in a vector, its address might change all the time, because the way that Rust works, when vectors grow, it might move to another region of memory so that it can allocate a little bit more, and then a little bit more again. And he says this is not really as inefficient as it sounds. As the vector grows larger and larger, it happens less and less often. But the real problem behind this is that you can't depend on the address of your element staying the same. And there are a lot of use cases where you want to hold on to those addresses while also adding new objects to your arena. So he talks about basically the ultimate end, or the ultimate product of this post, is this great table comparing all the different features of the different arena libraries that are out there. And in a nod to Sylvain's previous post, there's a lot of arena libraries out there. There's definitely a lot of fragmentation here. And so this is really helpful for finding the right library that does what you want it to. And he talks a little bit about the kinds of features that are available, that are commonly used when dealing with arenas. And so he talks about how some arenas will directly give you references, but some are based on indices, and you might even need to have access to the arena to use the indices. So ownership and mutability matters here. Talks about how some arena allocators assume that you'll only ever allocate it. You'll never free, that it'll just stick around until the project is over, which might be what you want, but you might want a freeing arena. And he says most freeing arenas use a linked list of free spots, or a free list, although there are some objects or options like garbage collection. And there's one library that can even shrink itself, but he says that for performance reasons, shrinking usually isn't a very good idea. He talks about how some arenas will run the drop handler that you expect in Rust, and some won't. So that's something to be really mindful of. He talks about how an arena often isn't based on a vector, but you might want to iterate over those objects in order. And so does the library support that? There's also talk about if your arena supports deletions, the arena has to be careful not to reallocate that region back, reusing the ID that it previously gave you, so that you don't access data in that region that you aren't supposed to. But then there are some arenas that don't care and let you do that yourself and figure that out yourself. There's things like concurrency and deduplication that he talks to. It's really a comprehensive list of features. So if you need to hold some data in memory and ensure that it doesn't get deallocated or cleared out or dropped right away, reaching for an arena might be what you need. And this is a great overview of the options that are available and what's different about them. All right, this article, I loved the play on words that the new stack provided. Author Daryl K. Taft talks about DARPA and their tractor library. And so the fun headline is, can DARPA's tractor pull C to Rust for memory safe overhaul? Obviously a reference to tractor pulls. Tractors are awesome, but do they actually provide value in the C to Rust ecosystem? That's the question. There's an ambitious DARPA program right now. DARPA is the Defense Advanced Research Projects Agency. Gotta love government acronyms. They announced the Translating All C to Rust, the tractor program that is trying to automate the translation of the world's legacy C code. So I think this is a position that the aforementioned Linux kernel maintainers probably would be very offended by. But the concept that DARPA is looking at is that we need to get rid of all this unsafe C code, which is a position that I support in many cases. It's not absolute. There are definitely exceptions to that. But I think in a lot of cases, it would be a good idea to move to a memory safe language like Rust. And Rust is definitely the best memory safe language available to us right now. So DARPA wants to do it automatically. DARPA wants to rewrite C code into Rust, which sounds like over ambitious, sounds like superhuman or even super computing. Like this feels like something that's a pie in the sky kind of goal that are they ever really going to approach it? And so you'll see some of the comments on here kind of supporting that idea that, whoa, this is an ambitious goal. Is this even possible? Should we even be talking about it? But then the article presents some viewpoints talking about the value in it, that yes, you may not be able to just automatically point this translator to a C library and immediately get back some working Rust code that's going to be perfect for what you're trying to do. But there is something to be said for making the effort. There's a quote here that says, still, who is it? It's Tim McNamara. Oh, I've got an article from Tim McNamara I will highlight next really quickly, but he's the founder of Accelerant and author of Rust in Action. And he says, I'm quite skeptical that the stated aims in the abstract are even possible, which I think most programmers that have some context here look at this and have that exact same thought. Is this even possible? But he says, still, the worst case is that the software industry gains more information about how to translate old code into memory safe alternatives. The best case is that we can gain a tool that can do it, but the worst case is that we get at least some information about here are the problems, here are the challenges. And ultimately, I think there might be some portions of a code base that we can move to Rust, even if it's not the entire code base. So it says, even if you don't move the whole thing, maybe this would help move portions that are well suited to automatic rewriting, which makes a lot of sense to me. I think it's an interesting goal, and there's a lot of reasoning why Rust is better than C for a lot of these really critical workflows. They cite Wallach, but I can't remember who Wallach is, so I'm trying to look back. So sorry, read the article to find out who that is, but he has a great sentiment, I think. He says, Rust forces the programmer to get things right. It can feel constraining to deal with all the rules it forces, but when you acclimate to them, the rules give you freedom. They're like guardrails. Once you realize they're there to protect you, you'll become free to focus on more important things. And I liken this to the jump from dynamic types to static types. It can feel really constraining and frustrating, and you feel like you're solving all these edge cases that don't really matter. But once you understand, they're there to help you. They're there to guide you. They're there to point out things that may go wrong. They really become a tool, a benefit, a trusted ally to help you with your code. And I think the ownership and lifetime tracking system that Rust introduced is the same way. It becomes another ally to help you understand the things that could go wrong. And you don't always want to deal with that. You don't always see how likely something is, but then that's how production bugs happen. That's how they get there, is that you don't expect something to be such a big deal, but it is. So I think these guardrails are constraining, they're stifling at times, but they're also a major ally. They're a major help to get you to your goal without dealing with the same kind of stability issues that you would see in other languages. The feeling of being stifled, I think, only lasts so long before you start to finally build an instinct around what it's doing for you, the kind of things that it's preventing you from getting yourself into. So DARPA is going to be hosting public competitions. They're particularly paying attention to large language model powered solutions, which is definitely interesting to me. I've seen some attempts at automatically rewriting code in the past in the JavaScript community, especially when we were going through the whole ECMAScript transition. There were a lot of code generators that would rewrite the code for you into supposedly perfect ECMAScript. And in the experience that I had in the JavaScript ecosystem, it was never very good. It would give you something that might give you an idea of what you needed to do, but it wasn't code that you could just rely on right away. You had to make a lot of alterations. And so I expect that's what it's going to look at like here. And I think that you'll end up, if they have a good product coming out of this, it'll be something that you can point at pieces of code, at certain portions of the code base or components in the code base, while you'll have to translate other parts by hand, or just embed those particular strategic portions as Rust while still keeping it C on the outside or something like that. I think that that's the kind of ultimate goal that you'll see at the end here. I don't know how much mileage they'll get out of the large language models. The article quotes Holger Mueller, an analyst at Constellation Research, and he says that even the best generative AI models are not right now generating code at the same level that you'd get from an experienced programmer. And so, yes, LLMs are interesting. They provide some really cool results. I don't know if you'll really be able to rely on them, though, and it will likely come out like I saw in the JavaScript community, where you'll get a good first pass that you'll have to do a lot of alteration to really get it usable. The executive director of the Internet Security Research Group, Josh Aas, AAS, he seems more hopeful. He says, while the work of moving critical code from C to Rust does seem daunting, we've already made a lot of progress. Today, there are memory safe and high performance options for TLS, NTP, pseudo, DNS, and AV1 video decoding. They really have made a lot of progress in some of the underpinnings, some of the low level things like that. And this tool ultimately it's not likely to be a short-term or easy answer to the challenges. The article quotes, it's reasonable to expect that this is an aim for the moon. Even if you miss, you'll end up among the stars type of project, which is definitely an interesting perspective. You don't necessarily expect the central goal to be accomplished, but you expect there will be a lot of benefit coming out of the journey to get there. And that's really cool. All right, to finish up, I will go to the Tim McNamara post. This is really quick. Tim McNamara posted recently about all the amazing Rust podcasts that have come out this year. And I second that. I think there's a lot of great shows going on. He doesn't mention my show because my show is just starting out again after a long absence. I assume that's why he didn't mention mine. Just not aware of it yet. But he calls out some great Rust podcasts, not only ones that have emerged in 2024, but ones that are continuing in 2024 with strong content. And so first calls out Q&A with Friends from Irene. I won't attempt to pronounce the name, but there's also Rust in Production, which is hosted by Matthias Endler, who I've cited some blog posts from his Rust consultancy, corrode.dev. There's the Self-Directed Research podcast hosted by Amos Wenger, Faster Than Lime. I love Amos's perspective on engineering. I love his opinions on Go versus Rust and the strengths and weaknesses of each. And then he co-hosts it with James Munns, who I just mentioned earlier in this podcast, who is a founder of Ferris Systems and now runs his own consultancy, One Variable. That's a great podcast. And then he also calls out another one that is an interview podcast called Compose. And then, gosh, I don't even remember there being this many in the post. Rest Ship is an interview podcast by Marco Ianni. And then here's the greatest of all time, the long running fixtures in the Rust podcast world, the Rustation Station. I think the fact that we have so many choices available in Rust podcasts right now shows not only how adoption is increasing and more people are being interested in what you can do with Rust, but it's also showing how diverse and varied that Rust is, or how it can be used. It's used in so many different contexts by so many different types of developers for so many different types of projects. And I think that's really a testament to how flexible and how stable the language designers have been able to make the language where it's useful for so many different things. And we've got a lot of people talking about it with the articles that I'm highlighting in my podcast, or other podcasts like Tim McNamara highlights. There's a lot of activity, a lot of enthusiasm and excitement right now. So definitely plug in, definitely start paying attention and watching and listening. And I think the Rust enthusiasm might be infectious. You might find yourself really pining for more safety, more stability, and more performance before you know it. All right. Well, thank you for hanging out with me for this nearly an hour and talking through the posts that I've been interested by over the last couple of weeks or so. I plan on picking the pace back up. Even if I don't make a weekly cadence, it'll be a semi-weekly cadence. And I appreciate you watching, and let me know what you thought in the comments or on Discord. Thanks again.